Now, it gets slightly more complicated in the case where there can be only one policy. And that's because, for the very reason that we described in the first quiz, where if I know with certainty there's only one policy and I know with certainty the human gives me the right answer, the moment you tell me that some action is correct, I now know something about the other actions. So it becomes complicated. Somehow what you've told me about a second action tells me something about the first action. And when you go through all the math, it's still a multinomial. And when you go through all the math and do the derivation, and the derivation is available for the students, you end up with this quantity, that the probability that a particular action A is optimal given a sequence of labels is what we've seen before. It's C raised to the delta sub A times 1 minus C raised to all the other evidence that we have from the other actions. And then there's a normalization factor, which I don't write out here. And this corresponds to what we did in the last example where we wrote out 0.8, 0.2, and 0.2, and then normalized everything out.
And let me make sure I understand that. So we have 1.2. Oh, the delta is 1.
Yes.
No, but it's 0 for the other guys. What's delta J? Delta J is for the other actions.
Yes, this is the difference between the times you said yes and no for every other action that isn't the particular action you're asking about. So this provides evidence from the other actions.
Oh, I see. And then we're going to normalize. So
Right.
maybe that squiggle equals wants to be like an alpha, like a proportional to symbol.
Yeah, sure. I usually write squiggle, where I grew up in the South, that meant approximately. But there. That make you feel better?
Much better, because it's not really approximately, it's actually proportional to, which means we're going to have to normalize afterwards. So that we get the 0.8, we get a 0.2 and a 0.2, and then when we normalize it, we get the 2/3, 1/6, 1/6. Awesome.
Exactly. And the right thing kind of happens there. And you could write out what the normalization factor is, and then we don't have to have an alpha here. We can have an equals, but it's big, long, and hairy. And it's just much simpler to actually ignore it, do this part, which is really easy, and then do the normalization afterwards. More to the point, since what we care about is a policy, we only care about which one's maximal. We don't actually care about the actual probability.
I'm forgetting why we care about a policy.
Remember.
Because because ultimately we're combining this information to figure out what action to take.
Right.
Got it.
If all we're doing is listening to human beings, then when a human tells us something, we want to pick the action that's most likely to be optimal. And so it doesn't matter what the actual probability is so long as we have the ordering right. And so we don't have to normalize. We don't have to know the probability. We just have to make certain we get the maximal one right.